Hey guys, welcome to Learn and Build. And today we're going to discuss about DMA, Dynamic Memory Allocation. In last class, we have discussed about file handling or file input output operations. So in last class, we have discussed about how to take data from a particular file, how to write a data into that particular file. If we have some, specific data, maybe in numeric or text format that we can store into a separate file also, right? So in this lecture, we will be looking out to basically, manage or optimize the space, right? So this topic which I'm taking it from last, I have discussed it in last couple of classes also, but today like we'll be really working on this particular topic, and we'll see whether what is the real importance of DMA into any programming language, right? So without wasting time, let's just jump on to understanding what are the actual inside topics for this DMA do we have, right? So we'll be talking about the importance of DMA and what is this DMA basically, and then we'll be having four specific functions. We have calloc, free reallocation, or memory allocation. These kind of four different functions. So four different functions, or you can call them as the command also, right? So let's see how can we use those memory allocating commands or functions in our programming language. Okay, so with respect to C, let us understand what is this memory allocation part. Okay, so we are discussing about DMA, dynamic memory allocation, right? So this is one of the biggest part in programming language for many different reasons. The one of the biggest reason is that it optimizes our space. It optimizes the space, right? And because of space optimization, right, your speed, or you can say execution of program executions, becomes faster, right? The programs which are actually dealing with, one of the program is there, this is your one first program, and this is your second program, suppose. So first is non DMA, right, without DMA that we have prepared, and with DMA that we have prepared. So there'll be a huge difference between both of them while working or talking about the execution part. Okay, so we are talking about the execution part. Let us understand how this execution will be faster. Okay, so suppose, let us take an analogy, right? Let's take an example. Suppose I have declared an array, right? I have declared an array. Maybe I have 1 2 3 4 5 6 7. Okay, so I have stored some data over here, maybe 10, 15, 13, 25, 8, 70, 89, maybe 75, right? So this is how we have stored the data. If we'll talk about the memory locations of each of them, right? So it in array, it starts from 0. So this is 0 as location, this is first, this is second, this is third, fourth, fifth, sixth, seventh, right? So overall number of locations that we have got here are 8, right? So 8 locations for data storing, right? And if one particular data is going to be stored with 4 bytes of space, right? So 4 into 8 is 8 fours are 32, right? So 32 bytes of space is going to be occupied in this case. Okay, but what if, like, just in one analogy, in one example, this was the example for array memory allocation, right? Now let's talk about dynamic memory allocation. This was array memory allocation, right? AMA. Now let's talk about dynamic memory allocation. What if, like, we had 8 locations of space, right? And we want to increase to more data, right? We want to store, suppose, 32 and 83, these two more values, right? Now what will happen, that then we have to go back to this particular place where the array was available, and then again we have to change in our declaration of this particular data type, right? So we need to increase the data. This was the first case. This was the first case. In second case, what if we have same amount of space, but we want to delete these two information, we want to delete this information, right? These two information must be deleted. So or else just you have only five or six locations of data, then what will happen? These two spaces are going to be wasted, right? So we want to use these two spaces very carefully in such a case that only a specific optimization of this data or this location, this memory should be utilized, right? So if we are required, instead of 8 we are required 10 locations, then in running program or during the execution of the program, automatically the space of this particular data of this particular memory allocation should be increased by two more locations, right? And likewise, if we want to free up some space, if you want to delete some data, that we can do it through this particular location, for making it for six location only out of 8, right? So these are the two important aspect that we have. Either we want to increase or decrease the amount of locations or amount of area, right? In declaration of any particular variable, then this thing could be happening with the help of DMA, right? So DMA, how does it help us to actually reallocate or allocating some amount of data, right? So in DMA, wait, in DMA what happens, we have got four functions. We've got four functions. The one is memory allocation, malloc, or some people used to call it as malloc, right? Then second is calloc or calloc, contiguous allocation, right? Third is free, right? Free. And the fourth is reallocation, realloc, realloc, right? These are the four different functions or commands do we have in this DMA, okay? So let us understand all of these commands one by one. What are the differences and what are the importance of these four commands that we have? Okay, so let's talk about malloc or malloc, memory allocation, right? So this malloc or memory allocation, this helps us to allocating our space like in this way. Suppose we have a space here, and we are, let me put it to the consideration for any particular syntax of malloc also, right? So let me write down the syntax. Suppose I am declaring a pointer, right? I'm declaring a pointer of integer type, right? So how it will help us, this function is going to help us in real, right? So in int pointer is equal to int malloc, right? And the amount of space, suppose that space that we want is n multiplied by size of size of int, right? So what will happen in this function declaration, size of int means int used to take 4 byte of space, suppose in case of 32-bit compiler, okay, 32-bit compilation technique or in compiler space, right? So we have 4 bytes of space requirement for integer, so size of int will be 4. If we give a value for n is suppose 10, so n multiply by 4 is 20, sorry, 10 multiply by 4 is 40, so it will give us 40 amount of bytes. So 40 amounts of bytes will be allocating in this specific space, and that will be of 40 bytes long, right? So from 0th byte till 30th 39th byte, this will be a particular space that will be assigned to this particular pointer variable, okay? This is the definition of malloc, okay? Now let's talk about the second case. There we have calloc, okay? Yeah, so let's talk about calloc also, right? Okay, so how do we initialize it? Int again a kind of pointer that we have, int, right? Either it can be int or float or character, whatever you want, right? Then calloc. So instead of, again there'll be an amount of data that you want to store, comma, instead of multiplication, here it takes two different arguments. So n comma size of, is a function of int, suppose, right? So in this case, if value of n is again 10 and size of int is 4 byte, so what will happen again, it becomes it becomes a need of 40 bytes of space to allocate through calloc function, right? So what will happen here, again there'll be 40 bytes of space requirement, right? Or you can say 40 bytes of space will be accommodated in this particular area, but in the small chunks or packets or boxes of 4 bytes, right? So n number of, I mean 10 amount of boxes of 4 bytes each will be allocating here, right? So 4 bytes, 4 bytes, 4 bytes, like that, there'll be 10 boxes, 10 blocks. So it will be a blocking mechanism. So it will be a like, you can say, it will be a link. Let me just put it in proper words. It will be a link of list. So list, what is this? If there is a list of 4 bytes, then there's a linking pattern of this particular list. Then so we'll be having 10 number of blocks for this particular explanation, right? For this particular calloc function. Okay, so this is how it is different from Malloc. Malloc is basically optimizing or associating a space of 40 bytes from 0 to 39 location. And here in calloc function, however, is going to store a data into 4 byte of blocks, right? So this is the beauty of working with calloc function. Now let's talk about the third one, that is free function, right? Free function, right? So free is very easy and very simple to operate or work with, right? So you had, suppose, this pointer variable ptr, so you can write free within bracket ptr, right? So sometimes it is called as deallocation also, deallocation, deallocation of memory, right? Deallocating memory, you can say, right? So you, if there's a space that you have stored or that you have specified for pointer variable ptr, either through calloc, or malloc, right? Through any method. I mean, you can say from 0th to 39th, or from first block to 10th block, right? In any words, right? You have made a particular association of, or you have specified a space of 40 bytes of memory area, right? Now you want to that you have some, in other words also, you can say this area was occupied with some specific data. Maybe suppose you have stored here 10, then here 15, 18, something like that, right? So 10 different values have been stored over here, right? Now if you want to free up this space, if you want to deallocate the data, right? Because pointer variable, if you will not free up this particular variable, then what will happen, the amount of space that you have specified here, that is 40 bytes, will always be allocated with your program, right? So program will be little heavy for 40 bytes long. So if you can use this function, if you will use this function, free function, in your program, right? So regularly, so oftenly, right? So what will happen, that 40 bytes of space will be freed. 40 bytes of space will be deallocated, and due to which your program will be little faster, it will be working little faster, right? Because the load on this program will be little less, right? So this is the beauty of working with free function. Okay, now let's talk about the fourth function, that is reallocation, reallocation, realloc, you can say, right? Reallocation. So there was a problem in a malloc or calloc function. You made a adjustment, or maybe you located some memory space of 40 bytes in both the cases, for malloc or calloc, right? Again 40 bytes. But here in malloc from 0th to 39th, in calloc from 0th block to 10th block, right? So 0th block is of 4 bytes. Cool. Yeah. So in both of these cases, what is the problem? If you want to increase, once you have declared some memory area with the help of malloc or calloc, right, of 40 bytes, you cannot increase this space anymore then, right? If you want to increase some more space by 10 more bytes, that you cannot do, that you cannot increase through malloc or calloc function. It will just specify a particular space in initial case of programming only. But during your program execution, if you want some more space to be associated with this particular memory area, then reallocation can work with you, right? So now if you want 10 more bytes of space, 12 more bytes of space, right? 12 more bytes of space, 12 bytes, right? So now overall number of bytes would be, suppose, 52. Here also 52. So 52 amount of byte, or 52 bytes, I would say 52 bytes. 52 bytes would be only possible, I mean 12 bytes will be only possible to increase in this area if we'll use realloc function. So these are the beauties of all these four functions in our DMA topic, right? DMA is important with respect to two things which we have already seen, right? So now let's try to implement all of these four commands and check whether how will it impact on our program, okay? And how will be actually using the definition of reallocation or free or something like that, right? So the syntax, if you will see here, for reallocation would be pointer reallocate, right? From that pointer itself, because this pointer will reallocate, and after reallocation the new pointer would be ptr itself. So same pointer is going to be reallocated, okay, comma, the amount of space that you need. So suppose that is n multiply by size of, suppose, int, right? So what will happen in this case? Size of int is 4 byte. Again, if we'll give the value of n is, suppose, 3, right? So total amount of bytes would be 12 bytes. Suppose already the size of ptr was 40 bytes, right? So overall space for this new pointer ptr would be 52 bytes. This is how it works, right? This is how it works. Now let's check the implementation part of this particular topic also, okay? So let me open online gdb.com, and this is our online IDE, right? So let me select the language, and now let's try to implement that, okay? Yeah, so first of all, let us create a pointer, right? So that is ptr, suppose, and one more variable, suppose n, amount of amount of data or amount of values that you want to actually store in ptr, okay? Now suppose let's take this value of n from user, okay? So enter the value of n, right? Scanf percentile d comma ampersand n, right? So we'll enter the value of n, then we'll allocate the memory area. So ptr is equal to int, so it should be of, again, pointer type, and then memory allocation within bracket n multiply by size of, within bracket, suppose int, right? So now this whatever the value will be entered by user, suppose this is 10, so 10 multiplied by 4, right? So overall 40 bytes of space will be allocated for ptr. Okay, so 40 bytes of space is allocated, but we did not store any data into ptr as of now. Okay, so if you want to store some data, suppose uh, we can take the data from user. Okay, so for, or in other words we can say, like, if I is equal to 0, I is less than n, it should run it for 5 times, 10 times, 20 times, 30 times only, till the amount of value of n is going to be reached. Okay, so I plus plus. Now if you understand this for loop, why we are running it, just to store some data into ptr. Okay, so how many values do we want to store? N amount of values, because the space is specified for n amount of values only, because here we have given the value of specified locations. Location would be n only, right? So now ptr of I means initially value of I would be 0, so ptr 0 would be equal to, we can put the same number or any particular maybe you can say I multiply by n, or we can say I multiply by 2, something like this, right? So what will happen, that initially value of I is 0, 0 multiplied by 2 is 0. So ptr of 0 would be 0. So again it will be increased by 1, the value of I will be increased by 1, so ptr of 1 would be equal to 1 into 2 is 2, right? So likewise some information would be stored in ptr, and whatever is stored in ptr, let's try to print that as well, just to check what is available in ptr. Values in ptr are, right, let's try to print, or first of all create a loop for the same amount of values to be displayed, I less than n, I plus plus, right, and print percentile d, but before that values of ptr are, yeah, so we can directly write ptr value. So pointer is of integer type only, right? Here we have stored values of integer type values. So percentile d would be coming up, percentile d comma ptr of I, right? And now let's see whether the values which we have, suppose we'll enter the value of n as 3, so it will run for 3 times only, right? And some data will be stored in ptr, and whatever is stored will be displayed. So the meaning of this program is something to display the data which we have stored into the memory allocation, and that we have done it through malloc function. Okay, again a bracket or something, yeah, so semicolon. So enter the value of n, suppose we are entering 10. So values in pointer ptr are 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, right? So 10 different values will be stored from 0 till 18, right? So number of values that we have got here are 10 different values. Let me put maybe backslash t, so that we can just make a space out of it. Let me run it once again. Yeah, so let me put it once again. So values are 0, 2, 4, 6, 8, 10, 12, 14, 6, 16 and 18. Likewise we are getting the data that we have got stored into this particular variable. Okay, so if this variable or this function or this command is not executed properly, so what will be the value of ptr then? So initially we have just declared the value of ptr, or we have just declared the variable of ptr, and initially nothing is available in any variable, right? And every variable will be just null, right? So initial value of ptr would be null, but after allocating or using this particular function, the allocation would be done in ptr, and then you can start storing the data into this variable, right? There could be n number of methods, various methods that you want, you want them to use for storing some data. So this is what I have used, just a simple example. How can we take user input just to tell whether how much amount of space that we are required, and then automatically some data will be stored in that, and we have displayed the value which we have stored into that function. Okay, now instead of malloc, if we can use calloc here, right? And here it will be just a small change, right? And that's it. Okay, let's just try to check whether it works for us. So say output is just same, right? So simply we have just changed this definition, or you can say, uh, you know the Kellogg function has two different arguments, n comma size of that particular variable that you want to actually allocate to, right? So here we have given the kind of definition of the function or command to be used in the same way that it is to be. Okay, right? So now you have used either Kellogg function or malloc function. If you want to free up some space, or you want to free up this particular variable of pointer, initially inside this entire program you have used ptr at many different places. You have used here, you have used here, you have declared the ptr value here, but but right now you want to just free up the space. If you want to free up the space, then free command was there. This will deallocate this pointer, and if you want to write some more lines of code, now you are free to do anything. Hello world, right? Whatever you want to do here, you can do it in n number of lines, right? N number of lines. We are not doing it. I'm telling you with respect to what actually you can do after this particular free up this particular space also. Maybe if you are deallocating the data, right? Then this program execution will be little faster in the remaining case of this particular program. Okay, because the amount of space that we have stored is now free. Okay, now let's try to run this code once again, maybe a different value. So 0, 2, 4, 6, 8, 10, hello world. So hello world has come, and this free command is working to just deallocating this space. Okay, so this is how we have seen three different commands. Now let us try to check whether can we increase the amount of space. So here, if the value of n would be 10, right, and we want to increase some more values. Okay, now after, let's not free up this space. Before that, let's try to do it. We want to increase some more space. So initially we have given the value of n, suppose it 10. We want to increase some more values. So the amount of enter the new value or value for n to increase the space, right? This space. So now suppose we have entered 10. Okay, so initially it was 10 here, and then again we'll enter 10. So overall 20 different location would be allocated, right? So let me just copy and paste this data. So what will happen, we have to run it from I would say from n. Yeah, so the value of n was initially 10. So from 10 that we want to run this loop from n to new n. Now that we cannot do, we have to take another variable, suppose maybe n comma m. Okay, from n to m. Okay, n to m, from n to m, and this data is cool, 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 cool. Everything is okay then. Yeah, so now overall the values would be 20. So values in pointer, let's start from 0 only. So 0 till m would be because the value of we are going to enter here would be 10 only, right? And because the value of n was 10, so 20 different values will be printing here. Okay, so m plus n, that's it. Let's try to run this code now. So value of n is 10. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Enter the value of n to increase the space. So this is not n, exactly it is 10, sorry, m. So now let me put, instead of 10 I can put maybe 6 suppose. So overall total number of location would be 16. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and then something that we have missed out in between. Okay, because the location is starting from one minus number, right? So 0, 0, 0, that's why it's not coming up properly. Okay, that we have missed out something over here in between. And we did not use, yeah, one more thing that is very important. We did not use reallocation command also. So ptr is equal to reallocation. So instead of this, this will be n, and then ptr comma n, and here we'll be having m multiply by size of int suppose, right? So now with this command we have reallocated the space for ptr, right? The space for ptr. Let me run this. Okay, let me try to run it once again because this server is not responding properly. Let me try to run it. Value of n is 10 suppose, right? Yeah, now enter the value of m suppose. Now I'm entering 6. Yeah, so now it's coming up again. There's a problem here. Yeah, again there is a problem here. Maybe the space here, something random is coming up, 1 3 5 1 2 1 2 1. So let me put some more amount of space and check whether what is the problem with this reallocation function. Maybe let's just put less amount of data, maybe suppose 5. Yeah, maybe 4. Let's try to check it. No, it's coming up in the same way. 0 2 4 6 8 and 0 something something something. So I might have written something wrong. Okay, yeah, maybe here it's not n. So initial value of n was suppose 5. So I will be 5, and yeah, less than m. Okay, m plus n should be there. M plus n. Yeah, this was the problem. Everything is okay. Suppose 6 initially, school. Now let's talk about 7. Yeah, so everything is going good. Maybe we have asked some more memory locations. That's why this aborted core dump something is coming up. But yeah, so you can check the location here from 0 to 4 6 8 10 12 14 16 18 20 22 24. These locations are being filled up, and this is possible just because of this was possible because of reallocating new memory space, right? So this is how these four command actually works, right? These four command works to actually optimizing the space, working for the optimization technique for the space in any programming language. here in C programming language that we have discussed about these four keywords, right? And we have made sure that this the importance of this particular data is really big, right? The importance of this data is really big. We have started working with the, let me put it through something else. Yeah, we have started with DMA, then we have come up with talking about these four commands, and then we have discussed the importance of each of them, right? Malloc, calloc, free up, free command, and DL, or you can say DL allocating memory space. And then we have gone through with reallocating this space, and we have understood the practical implementation part of this entire DMA. DMA is quite common term, however, but here we are talking about this DMA for dynamic memory allocation part. Okay, so I hope you have understood this concept of DMA, and you will be able to utilize in your programming concepts. So I'll share this code also with you, right? So that it should be there for you for your reference purpose. If you will find out some difficulties, you will have some doubt. This was the last class for C programming, right? So if you'll have some doubt, so we will discuss in doubt session. So try to practice everything from the scratch. The first class that we have started from the importance of C programming language, and then we have discussed about the keywords, the operators, right? Maybe the data types, right? Everything that we have started from scratch, right? So till this point, whatever we have discussed in last couple of classes, right? I believe that we have gone through with 20 to 22 classes overall, right? For containing the entire course syllabus, right? We have almost covered everything since fundamental of C till this dynamic memory allocation. We have a project also. We'll work on this project, right? In this project basically, as far as will be, you guys will be going through with the entire course, and if you find out some difficulty, we'll discuss in doubt class, and then after we'll try to start working with the project part. Okay, so let's just catch up in the doubt class. Till then, bye bye, and keep enjoying your journey of learning C programming. Thank you. Bye bye.